Newton's cradle provides a perfect example of how Newton's third law works. How? First, let's see what Newton's third law of motion states. The law states that for every action, there is an equal and opposite reaction. Therefore, in this case, as a ball at the right end comes down, it exerts a force that causes the ball at the other end to move in an opposite direction, but of equal magnitude. This third law is also referred to as the law of force pairs because for the law to work perfectly, both sides must have the same mass. Here's how they work in twos. And here's how they would work if both of the objects are acting upon each other at the same time. An important thing to remember is that if the masses are equal, they will both travel a similar distance after the collision is over. Here we see two basketballs of the same mass collide and travel the same distance. You may be wondering, what if the masses are different? Well, the law is still true. Even though the masses are different, in that moment of collision, the objects exert the same force upon each other. What changes, though, is their distance or height traveled. Usually the object of a smaller mass, in this case, the tennis ball, will feel the greater force act upon it and travel further than the basketball. So why is Newton's third law so important? Firstly, it explains why, when you punch a wall, your hand hurts. And secondly, it's the basis for an entirely new subject in physics, momentum, that mainly deals with how collisions work.